Hello my dear students, and welcome all of you to the third period of physics. We started with lesson number 8, that is motion, and also we discussed some of the topics from the lesson. Today we are going to discuss new topic from the same lesson. But before that, I want all of you to have quick revision about what we studied in the last two sessions. So we started with distance, displacement, speed, velocity. Last period we discussed about acceleration. I hope you all can recollect that what all we have learned. I understand, children, that suddenly the transition from standard 8 to standard 9 is not easy. What we learned in standard 8 was kind of easy science, but now you have certain things which you need to understand and pay attention and understand what exactly it is. So distance, displacement, with the figure you can identify, but I want to give you one example that when you come to the school and you want to reach to your classroom, you come to the classroom by staircase. You reach to 4th floor and you go to your class. That's the distance covered by you, actual path. But the moment you take the lift and reach to 4th floor, it is a shortcut distance to reach to your class, and that is displacement. Suppose you are coming in the car from your house to the school, and the car is moving with a constant value, that is the speed. The moment you see that there is a lot of traffic and the speed of the car is lower down, then because you are changing slight direction also, it becomes velocity. So speed gives you only magnitude, only the value, and velocity is nothing but magnitude plus some direction. Okay, then we learned about acceleration. If you see that figure, say you are walking to the school and you realize that now you are late, so you start running, you start moving faster. Now you are changing your velocity, right? That's acceleration, you are accelerating. Evening when you play, you are doing skating, the moment you see something in front of you, you slow down, you are again accelerating. The third figure, just see that the bee is buzzing and taking a round and moving ahead. Every time it is changing direction. So change in velocity, either you change in velocity or you change the direction and velocity, that's nothing but acceleration. So simple terms, like in our day-to-day life we use that, but now you should know the exact term for what action we are doing, right? After that, we also learned about the distance time graph, and this is like what type of motion is the object having. To understand that, suppose if the graph is there in front of you, you should be quickly able to identify from the graph that okay, the object has this particular type of motion. So if you can recollect, distance, time, these two physical quantities will give you the third physical quantity, that is speed, because speed is equal to distance upon time. So distance time graph will always give you idea about the speed of an object. If you see the first graph, it is a graph which is parallel to x-axis. Distance is not changing at all, there is a constant distance, though you are changing time on x-axis, it is a straight line parallel to x-axis. That indicates that the object is at rest. If you see the second figure, it is a straight line, but please be careful, see the figure, the line is not passing through origin, meaning is that its initial speed is not 0. And since after that it is a straight line, that means it is moving with uniform speed. The third figure, if you see, the graph is coming towards x-axis. That shows that the speed is reducing uniformly. Next graph, it is a curve, and I told you that curve will always give you an idea about the non-uniform motion. Now since it is a distance time graph, it is non-uniform speed. The object is moving with non-uniform speed. The next is again a curve, so it is also non-uniform speed, but in this case the speed is decreasing. And the earlier graph, there the graph is moving in the upward direction, that indicates that the speed is non-uniform, but it is increasing. Come to the last graph, again the initial speed is not 0. The object started with some value there, right? And after that, it is a uniform speed of an object. Now children, if you see graph 2 and graph 6, both are the lines moving in the upward direction. But what is the difference in that? In the second, graph, the object is moving faster with greater speed. And in the sixth graph, since it is moving slightly towards x-axis, it indicates that the speed of the object is less. So how you will identify that? You have to see the angle of the graph along with x-axis. Lesser the angle, more is the speed. Greater the angle, less is the speed. And the same you have to follow in case of the curved line graph, but exactly opposite. See figure number 4. Greater the angle, reducing the speed reduces. Okay, sorry, I said the other way. Greater the angle, greater is the speed. Lesser the angle, lesser is the speed. Clear? So in case of a straight line, lesser the angle, greater the speed. Greater the angle, lesser the speed. In case of a curved line, greater the angle, greater the speed. Lesser the angle, lesser is the speed. Right? Then we also discussed about velocity time graph. You look at the graph and you will be able to identify the motion. In the first case, it is a graph which is parallel to x-axis, meaning is that there is no change in velocity. The object is moving with constant velocity. So it indicates zero acceleration, because velocity time graph will give us an idea about the third physical quantity, that is acceleration. Second graph, it is a straight line passing through origin. So it will give us an idea about what type of acceleration the object has, and it has uniform acceleration. The third graph, the line is approaching towards x-axis, that means there is decrease in velocity and there is uniform decrease in velocity, and this indicates retardation or deceleration. Right? Come to the fourth graph. The meaning of the graph is initial velocity is not zero, because the graph is not passing through origin. And after that, since it is a straight line, it has uniform acceleration. Then the curve will always indicate a non-uniform, and in this case it is non-uniform acceleration. And look at the angle between the curve and x-axis. The angle is more, that means velocity is increasing. Sixth graph, now see, there are 3 lines drawn there. Every line you have to identify and tell me. From A to B, which type of acceleration? It is uniform acceleration. B to C is a graph which is parallel to x-axis. Which type of acceleration? Zero acceleration. C to D, the graph is approaching towards x-axis and there is a decrease in velocity, uniform decrease in velocity, and that indicates retardation. So this is how you have to identify the graph. If you see it again and again, you will be able to understand this in a better manner. So I want all of you to see this types of graph again and again, try to identify them, and then you will understand. The moment you look at the graph, quickly you will understand what type of motion the object has. So these were the topics which we discussed in the last 2 periods. Today we are going to start with the new topic of the lesson, that is equations of motion. There are 3 equations of motion. The motions are derived by Sir Isaac Newton. These equations are also called as kinematical equations of motion. The first equation of motion is relation between velocity and time, and the equation is V is equal to U plus AT. In the last lecture, I told you children that the initial velocity of the object is denoted by letter small u, final velocity is denoted by letter V, acceleration is A, and time is denoted by the letter T. If you see there on the screen, we have taken a graph of velocity time. Can you quickly recollect that velocity time graph gives us idea about which type of a motion? Exactly, velocity time graph will give us idea about acceleration. So this graph will give us idea about the accelerated motion of an object. So to derive equations of motion, we will consider a velocity time graph. If you see the graph, your graph is AB. Is it passing through origin? No. Its meaning is the object has certain initial velocity, and that initial velocity we have represented by letter U. So the object starts from point A and after some time it reaches to point B. So at B the object has final velocity, right? So OA represents initial velocity, and from point B, since B is a final velocity, so BC represents final velocity, that is V. From point B, we will draw two perpendiculars, one on the velocity axis, that is on y-axis, and one on the time axis, that is along x-axis. So BE is perpendicular on velocity axis and BC is perpendicular on the time axis, right? And we have joined these 2 points AD with a dotted line. From the graph we understand that BC is final velocity V and BC is equal to BD plus DC, right? Your simple mathematical rule. BC is equal to BD plus DC. Now AO is initial velocity U. AO and DC are equal, their measurement is equal. So DC is also U, right? So I can write BD plus DC as BD plus U, isn't it? And what is BC? BC is V. So I am getting the equation V is equal to BD plus U. So I'll just shift the terms and I'll get BD is equal to V minus U. This is your first, our term, first term which we are getting. Now you know the formula for acceleration. What is acceleration? Acceleration is change in velocity upon time, right? Change in velocity from the graph is what? BC is final velocity, DC is initial velocity, so the change in velocity is BD. So your formula will be small a, acceleration, is equal to BD upon time. And what is our time? Time is OC. So BD upon OC. But you have already calculated the value of BD, and what is that? It is V minus U. Substitute the values. So we are getting A is equal to V minus U upon T. Shift T towards left side. We are getting AT is equal to V minus U. Rearrange the terms. What are we getting? We are getting V is equal to U plus AT. And children, this is the first equation of motion, right? So first equation of motion is relation between velocity and time, and it is V is equal to U plus AT. Fix the equation in your mind. The moment I say first equation, this should quickly come from your side, right? Let's go to the second equation of motion. Second equation of motion is relation between position and time. I told you that what is position? Position is nothing but displacement. So it is a relation between displacement and time. Displacement is denoted by letter S. Initial velocity U. Final velocity is denoted by letter V. And time we denote by letter D. Right? So now since it is displacement and time, you know that when I have to calculate displacement from a velocity time graph, I told you that it is always area below the graph. In our case, what is our graph? AB is our graph. What is area below that? If you see the figure there on the screen, you will realize that I have colored that area. The area looks like the shape of a trapezium, but I have divided into two geometrical shapes. One is triangle and one is rectangle. Now since your second equation is relation between displacement and time, displacement is nothing but distance, so I will write displacement is equal to, or the distance is equal to, it is the area between the points A and B, right? So I will write S is equal to area OABC. OADC, that's your rectangle OADC, plus area of a triangle, that is area of triangle ADB, right? Because we have divided this trapezium into two geometrical figures. Now what is area of rectangle? Length into breadth. Area of triangle, half base into height. So length in our case, that's time, and breadth is u. Okay, so your formula will be S is equal to UT plus, now area of triangle, half base into height. In our case, what is base? AD is base. And what is height? BD is height. But what is BD? From equation 1, you have already calculated in equation 1, BD is V minus U. Substitute these values, you get S is equal to UT plus half T multiplied by AT. Okay, so if you solve it, we get S is equal to UT plus half AT square. And this is the second equation of motion. And second equation of motion is the relation between position and time. Right, children? So quickly, can you tell me what is first equation of motion? Yes, V is equal to U plus AT. And the second equation is S is equal to UT plus half AT square. All the equations you have to derive by taking the graph of velocity time, and it's easy. Now if you just see this video again, you will understand more clearly. If you see this again and again, the understanding will be more clear. Let's move towards the third equation of motion, and the third equation of motion is the relation between position and velocity. So it's displacement and velocity relation. Since I said displacement, again it is area below the graph. Our graph is AB, below that the area is trapezium. So I can say that the distance traveled by the body between the points A and B is area of the quadrilateral OABC. That is, it is area of a trapezium. Can you recollect the formula to find area of a trapezium? It is half into sum of the parallel sides into height, right? In our figure, which two sides are parallel? AO and BC are the two parallel sides. What is the height of this trapezium? OC is the height. So accordingly, write your formula. S is equal to 1 by 2. Sum of the parallel sides means OA plus BC into height is OC. Now we know all the values. OA is U, BC is V, OC is T. Put the values. So you get S is equal to U plus V into T upon 2. But from the velocity time relation, from the first equation of motion, V is equal to U plus AT, you can find the value of T. T is equal to V minus U upon A. This value you have to substitute in place of T. If you put this value, you get the equation S is equal to V plus U in one bracket, V minus U in other bracket upon 2A. Apply the formula A plus B, A minus B, that will give you A square minus B square. In place of A and B, here we have V and U. So V plus U into V minus U will give you V square minus U square, right? Take 2A towards the left side. So your equation is 2AS is equal to V square minus U square. And this is the third equation of motion. So third equation is the relation between position and velocity, and it is 2AS is equal to V square minus U square. According to your convenience, you can also write that as U square is equal to V square minus 2AS. Just shift the terms towards left and right, use your simple, mathematical rules, and you can twist the equation. So these are the three equations of motion. These are very, very important ones, and the whole physics, all the numericals of physics are based, this is the base of solving the numericals. These equations are very, very important. And like how you by heart your identities of mathematics, these three equations you have to just learn. V is equal to u plus at, s is equal to ut plus half at square, and 2as is equal to v square minus u square are the three equations of motion. Right, children? Now to have a quick revision of all the three equations of motion, now watch a small video, and after the video a quiz is there for you. So I want all of you to be ready with a pen and a notebook. I will ask you one question and you will just write down. There are options given for every question. You will write down the correct option, and then I will tell you what is the answer of that question. Right? So let's
racing is exciting, isn't it? But did you know that an average electric go-kart can pick up a speed from 0 to more than 96 kilometers in just 3.4 seconds? See how the go-kart's velocity is increasing with time. If you plot these values on a velocity time graph, the plotted points form a straight line PQ. The straight line indicates that the go-kart is showing uniform acceleration across 3.4 seconds. When the acceleration is uniform, using this simple graph, you can actually derive the three equations of kinematics. Let's derive the first equation of motion. To do this, we need to first select 2 points on the graph, A and B. We draw parallel lines to the x and y axis through A and B. Let's denote the initial velocity as the letter u and the final velocity as the letter v. Note that the velocity has increased with respect to time. The change in velocity per unit time is defined as acceleration. Let acceleration be denoted as a and time as t. Now in the graph shown here, AC represents the change in velocity. Looking at the graph once again, AD represents a line parallel to BE as well as the y-axis. So, according to the figure, AD is equal to V and BE is equal to U. You can see that AD is the sum of AC and CD. Also, CD is equal to BE. Therefore, AD is equal to AC plus BE. Substituting the values for AD, AC and BE, we get the equation shown here. This is the first kinematical equation. It shows the relation between velocity, acceleration, and time. Suppose in a given interval time, t, and a uniform acceleration a, the object travels a distance s. How can we find the value of s from the graph? Well, the distance traveled is given by the area enclosed within the quadrilateral BADE. The quadrilateral can be split into a triangle ABC and a rectangle BCDE. Therefore, S is the sum of the areas of the two figures. The area of a rectangle is equal to the product of its base and height. The area of the triangle is equal to 1/2 of the product of its base and height. Now BC is equal to ED, which gives the time interval t. Let us substitute the values for each of them in the equation. second equation of kinematics. It helps us find the displacement of an object if its initial velocity and uniform acceleration within a given time interval is known. We can find out the final velocity of an object if we know its initial velocity and the time interval during which it moves with a uniform acceleration. But is that the only way to calculate the final velocity? Let's explore. The distance s traveled by the object in time t under uniform acceleration a is given by the area enclosed within a quadrilateral BADE. Quadrilateral BADE is a trapezium. The area of a trapezium is equal to half the sum of its parallel sides multiplied by its height. Let us substitute the values for AD, BE and ED. We know that acceleration is the rate of change of velocity. On substituting the value of t in equation 2, we get the equation shown here. On simplifying, we get the third equation of kinematics.
Which type of acceleration is known as retardation? And the options are 0, negative, positive. What does a horizontal velocity time graph represent? 0 displacement, 0 velocity, 0 acceleration. A car covers a distance of 80 km in 2 hours. What is its average speed? Children, distance is given in kilometer and time is given in hours, but if you see the options, the answer is given in meter per second. So here there is a conversion. You have to convert and then find out the answer. Convert kilometer into meters and hours into second, and then your answer will be in meter per second. Which formula is used to find the acceleration of an object from velocity time graph? Change in velocity into time, or time divided by change in velocity, or change in velocity upon time. The third equation of motion represents relation between which two parameters? Velocity time, position velocity, or speed velocity. Which of this is the second equation of motion? See the option there on the screen and write your answer. Dash acceleration is called as retardation. Negative, positive, 0, constant. Which formula represents the third equation of motion? See there on the screen and write your answer.
So children, the answers are flashing there on the screen. Please you tally what all answers you have written. I hope you must have got it correct. Tally all the answers and check out if it is wrong. Check all the questions once again, and then we can always discuss the questions. And with this, we will stop for today's session and see you all in the next session with a new topic. So bye and take care.